Okay, here we go. Welcome to Classwork 11.1. I've picked out a couple problems to just clarify. Again, I don't think it's a terribly difficult lesson, but I'm never going to assume, and always happy to go over what I think are some of the trickiest ones or most important ones. So we got page 751 doing 1 through 21 odd, and we're going to start with number 5. So number 5 asks you to identify the different lines in here. And so the first one is a chord. So where do we see a chord? And so a chord has to have endpoints on the circle and extend all the way through. So this will not work. It does not go all the way through. This does not intersect in two different points. So QS is my only option. And chords are line or segments. So they have an endpoint, so I would write it with a solid line like that over the top. Then when it asks for a secant, where do I have any secant lines? A secant line has to extend all on through a circle. So a secant line has to extend on through a circle in two different places. So again, this line is not going to work. It only hits in one spot. This one does not extend all the way through. So secant would be QS. I would, however, write it slightly different because now I'm talking about the entire line. And so I'll put my little extended arrows there to show secant QS. Now a tangent line, do I have any tangent lines? Different between a tangent and a secant is the tangent's going to hit in one location instead of two. And so that, of course, is our line right here, line ST. Because it only hits the line in one spot, and it doesn't ask us here for a point of tangency, but point S would be our point of tangency. Fun little review. Also, we know that because this is a tangent line, we know that this angle here must be a right angle because this is passing on through the center of the circle. Okay, a diameter. A diameter has to cut, is basically a chord or a secant line that passes through the center of a circle. So it has to go through the center. And so that would also qualify as QS because it goes all the way through. Notice RP does not go all the way through. That's not going to work. So again, QS is also our diameter. And finally, radii, like spokes on a wheel. Whoops, if I can spell it right. Radii, kind of a cool word, no I here. Radii are anything that extend from the center of the circle to the edge. And so I actually have 3 spokes on this wheel, or 3 radii, and that would be PR, PS, and PQ. So 3 different radii, and you would know these are all congruent because they're all the radius to the same circle. Okay, so that's number 5, learning to identify your different lines. Again, a chord and secant can be the same thing, but a secant must pass all the way through, and a chord has to be able to identify its endpoints. All right, number 7, we're dealing with tangent circles, and it says locate the length of the radius of each one. So the radius. Oh, can't spell today. Radius. So that's the distance from the center of the circle to the edge. And so circle R, we can see it goes up 1, 2. And every direction should be the same, and it's 2 in each direction. So 2 units for that circle, radius of 2, and for circle S, 1, 2, or 1, 2, or 1. So it also has a radius of 2. Okay, then we need to find the point of tangency. Point of tangency. That is where did the 2 circles touch one another, and that is this point right here. Okay, and it might sometimes look like more than one point, but you can always kind of see what's that where they start to curve toward and away from each other. It's right here, and so that is on the x-axis over 1 and the y-axis up 1, 2. So that is the point 1, 2, where that is the point of tangency on these circles. And then finally, we're supposed to write the equation of the tangent line of this point. So what line would then go through the point of tangency, like here's a tangent point and the line through the point of tangency. What's the equation of this line? Okay, now before you panic, let's see, this is the tangent line. We can remember that vertical and horizontal lines are very easy to write equations for because it is simply the point that it passes through. So this line is going through x equals 1. So if the point goes through x equals 1, that is just our equation, x equals 1. Vertical lines, horizontal. If it was horizontal and it was passing through 1, then it would be y equals 1. but it's not going this way through y, it's going vertically through x. And so our equation is simply x equals 1. Okay, so counting radius or radii, finding the point of tangency, tangent line. Again, lots of talking or diagramming, but actually finding the answers is pretty simple. Number 9, we get to practice our second theorem about external points and tangent lines. And again, the reason you need to know from the homework the relationship between these two is it tells you how to set up this equation. We're supposed to find jk. I need to know this distance. Well, luckily, I know that if I have two tangent lines and they hit upon the same external point, that this line, jk, must be congruent to jl. And so that allows me to write a very simple equation. 4x minus 1 must be equal to 2x plus 9. And so now I can simply solve those and solve for x. Minus 2x, minus 2x, so 2x, we'll switch back to red, 2x minus 1 equals, that's canceled out, 9. We're going to add 1 to both sides. I'm working slowly here. Cancels out. So we get 2x equals 10 divided by 5, divided by 2. Can't jump into the answer already. And so x is equal to 5. Now, before you put that as your answer or click on that on a quizzes test, realize, again, the question asked us for jk. And so the answer is not 5. I need to plug 5 back into this equation. So 5 times 4 is 20. 20 minus 1 is 19. So jk is equal to 19. And that is my final answer. And again, because these are equal, I should be able to plug 5 in here and also get 19. And I do. 2 times 5 is 10. 10 plus 9 is 19. Okay, but again, you'll run into it. That's a very simple version of why we learned this theorem, is and we'll know that these two distances are congruent. Okay, 2 more shorter problems to just review, 19 and 21. Just telling whether they are sometimes, always, or never true. Number 19 says, a circle, a tangent to a circle intersects the circle at 2 points. So a tangent to a circle, which by definition has to hit the circle in only 1 point. So will it always, sometimes, or never hit the circle at 2 points? Well, it's by definition, a tangent line only hits at 1 point. So it is never going to ever hit the circle at 2 points. If it did, then it would be a secant line. So this would have to be never. A tangent line can never hit a circle in more than 1 spot. So it cannot hit it in two points like the question asks. Never. It breaks its definition. 21. A tangent to a circle will form a right angle with the radius. Okay? So if we draw our circle and we draw a tangent line and it says when, always, sometimes, or never will the point of tangency and the radius, so these two, how often will they form a right angle? Well, if you remember from the homework, that is by definition true. That anytime you draw a tangent line, find the point of tangency, connect it to the radius, the angle formed by the radius and the tangent line is always 90 degrees. Okay? So that is always, sometimes, or never. That would be always, because that was the theorem we learned from this chapter, or want to learn from this lesson. So always. Okay? So hopefully that helps. Again, hopefully this shouldn't take you too long. Not a lot of calculations, just practicing some of the concepts and definitions. But again, reach out if you have questions. This is our last chapter of the year. We'll be doing a couple lessons and then finishing up next week with a test, and we will be done. So hope you're having a beautiful week, and reach out if you need help or even just want to say hi. All right, take care.